And I want to look at some practice, I guess, problems or questions on atomic structure. So you should be able to answer these solely through the periodic table. Okay, so let's check this out. So what you're going to find here is that it goes like this. So the first question that we're going to ask here is that is the isotope 12050 tin the most common isotope? So your job is to figure out, is 12010 the most common one? So what you're finding here is that you're going to have to do what? You must compare two different isotopes. One is the one that's given. Which one's the one that's given? Well, it's 120, 10, and the other one, the one on the periodic table. So you got to compare these guys here. So which one's the one on the periodic table? So I have an image of it. Here it is. So this is the guy on the periodic table right here. Okay. So when you look at the one on the periodic table, look, I got a round. So if I round, I could see that this is 119, this is 50, and this is SN. You got to calculate both of them. Let's calculate both of these here. So here we go. Let's calculate them. So if I calculate this one, this guy has 70 neutrons. This one has 69 neutrons. You could see right away that the isotopes are already different, because what determines the isotope? The number of neutrons. But both of these are 10. Why? Because they both have 50 protons. But since all of these are neutral, I should have 50 electrons in each case here. Now, which row is it in? Let's go look at the periodic table. So if I go and I look at the periodic table, we got to look for element 50. So here we go, element 50. Element 50 is right here. That's 10. So then I'm going to go, I come over here, you could see that it's on the 5th row. So what do I expect? I expect that the 119, because it's not on, remember, the first 4 rows are typically the one on the table, because 10 is not in the first 4 rows. We would think that the one on the right, the 69 neutron one, is not the most common one. Okay, so what we expect here is that this guy is the 5th row. So this tells us is that this guy here, that because it's in the 5th row, this is likely less common. So what am I going to go do? I'm going to go get Wikipedia. Let me go get the image for Wikipedia here. Oh, I did not share my screen. Oh, man. Sorry about that. So I went in and I wrote the 5th row, and then I wrote that because 69 is the one listed on the table, but it's in the 5th row, we would expect that it's not the most common. So here I go. I'm going to go get this guy now. So these are the isotopes of tin. So this is a little bit too big. So I got to make this smaller. And so when you look at that, look at isotope 120. So if I look at 120, this is 120. Look at 119. 119, look at that. So what you're seeing here is that this guy is going to be what? This is the most common. At what percentage? The most common is at 32.58%. This guy is the least common, and you could see here is that, or it's less common, so then this guy's 8.59%. So that's what you got to do. So why is this the most common? The most common has what? So the most common at 30 has how many? 70 neutrons. This one is the least common because it has what? It has 69 neutrons. It's the number of neutrons that tell you what it is. So I want to do the exact same thing with the other element, uranium. Let's go look at uranium here. And so what I'm going to do here is that I'm going to ask the exact same question, right? I'm going to ask the exact same question as I did over here. But then I'm going to change it a little bit. So in this case, this is 2. And the one that I'm going to look at is going to be 236.92 uranium. Which is the most common? Is 236 the most common one? Or the one on the periodic table? Let's go look at this thing here. So if I do that, what's the given in this case? Well, the given is 236.92 uranium. So if I calculate, and this other one is going to be what? On the periodic table, it's 238 uranium. So then I got to calculate the number of everything about this atom structurally. So this guy has 144 neutrons. The one listed on the periodic table has 146 neutrons. But because both of these are uranium, they have to have the same number of protons. They have to have the same number of electrons. Now I got to go find the number of shells. So what do I got to do? I got to go find element 92. Let's go to the periodic table. So if I go to the periodic table, element 92 is this guy. You could see that this is on the 7th shell. Okay, so now we know. So when I come back up here, right, I come up here, what you're seeing here is that I now know that this has 7 shells. 7 shells. So we would think that because this is not in the first one, we would expect that this guy's going to be what? Which one's going to be less common? We don't know which one's going to be it. So what we would expect here is that the one on the periodic table is likely not going to be the most common. But check this out. Look at what Wikipedia says. It's going to be too big again. Here, let me try to make this a little bit smaller. So when you look at this guy, look at the numbers. 236, this is 236. This is extremely rare. 238 is the most common isotope. So this guy here, this is the most common. And it's the one listed on the periodic table. Whereas this one is way less common. In fact, 236 was made to be the first bomb. And so you had to manufacture it. So my point here is that when you look at this stuff, just by looking at the row number and saying it's in the first four or it's in the, after that, it's complicated. It's not so easy for the isotopes.